Good morning. Today we're going to continue drawing covalent compounds, and we're going to first start with checking the assignment from yesterday. So we'll start with checking example 3, 4, and 5. Okay, so example 3 was S2. All right, so based on that, I know I have 2 sulfurs because the subscript is 2. Sulfur is in group 16, so it has 6 valence electrons. Okay, since it's the same element bonding with itself, we're going to look at what does it need. Each sulfur needs 2, right? One on the left side and one on the bottom. So I'm just going to connect the valence electrons that would probably bond together, and I'm just going to clean it up over here. So I drew 1, 2 lines in between sulfur and the other sulfur. All right, so there's the 2. All right, here's the 2 electrons on this sulfur. Here are the 2 electrons on this sulfur. Now there's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So when you're telling me about this molecule, there's 1 double bond. Okay, so 2 lines make it a double. And how many unshared pairs of electrons? 1, 2, 3, 4. So there are 4 unshared pairs. Okay. The next one that you had was N2. So this is dinitride. So I'm going to draw 2 nitrogens. And nitrogen happens to be in group 15, so it has 5 valence electrons. Now, what does each nitrogen need? Well, this one needs 1, 2, 3, and this one needs 1, 2, 3. So they're not going to form a single. They're not going to form a double. They're going to form a triple bond. I'm going to clean the diagram up over here. So here are my 2 nitrogens, and I drew 1, 2, 3 lines in between them. And since this molecule exists in space, I can turn it. So I'm just going to draw these unshared pairs over here. So in talking about this molecule, there's 1 triple bond, and there are 2 unshared pairs. This is the point where some students normally ask, can you have a quadruple bond? Can you have something with 4 bonds? And the answer is no. I would hand you the molecules in class, and I would tell you to try and make it. A quadruple bond isn't able to be formed because it's unstable. Single bonds are the strongest. Double bonds are in the middle. Triple bonds are the weakest. Just because there's 3 of them does not mean it's the strongest. So a quadruple bond can't be formed based upon how the molecule exists in 3D. It's too much stress on the bond, and the bonds break. They never can be formed. All right, so our next one is CO2. Oh, yeah. Maybe some of you guys figured this out with the clue that carbon likes to be the central molecule. So we have CO2. All right, so I have 1 carbon, and it has 4 bonding sites. So then I have 2 oxygen. I'm going to draw them up here. And oxygen is in group 16. Sorry. Okay. Each oxygen needs 2. All right, so this guy needs 1, 2. This guy needs 1, 2. So they need a total of 4. Well, what does carbon need a total of? Carbon needs a total of 4. So every compound that I give you is going to be able to work. So you're going to draw your lines here and here. So how can I clean that up? Well, carbon's the central molecule. It likes to exist in the middle. It has 2 lines extending to an oxygen. And that oxygen has 4 valence electrons. It has 2 lines extending to this one. And this one has 4 electrons. So in telling me about this molecule, there are 2 bonds here and 2 bonds here. So that's 2 double bonds with 4 unshared pairs. So carbon dioxide, if you were to take a look at it, it's what we call a linear molecule. It likes to exist in a straight line because these valence electrons are trying to get away from these valence electrons, and these guys over here don't want to be close to anything as well. So they push that molecule into a straight line. All right. Just going to put a couple of other examples up for you to see if you can do it. So here are some other cases that you might see. Let's call this example 6. Let's do CH3Cl. And then let's do, I'm trying to think of a different one that we haven't done yet. Example 7, let's do pH3. Okay, so go ahead, pause the video, try and do these. If you are still stuck, at least draw the Lewis dot diagrams for them, okay? All right, so you should have paused the video and tried these on your own. Here's my first one. I see I have a carbon, and carbon likes to be the central molecule. So here's carbon's 4 valence electrons. All right, so what do I have that next? Well, I have 3 hydrogens that each have 1 valence electron. Can you picture where these 3 are going to go? They can go anywhere they want. So I'm just going to draw this one being bonded here, this one being bonded here, this one being bonded here. Okay? And then I have a chlorine. Chlorine has a total of 7, and it needs 1 more right here. So it's going to get that 1 right there. All right. So in analyzing this, how many bonds do we have total? We have 1, 2, 3, 4. 4 single bonds. Around this chlorine, there are, oh, I drew too many. Did you guys catch that? Around this chlorine, there are 3 unshared pairs. All right, so that's kind of telling me about the molecule. All right, the next one is pH3. Phosphorus is in the middle with 5 of its own. There's 3 hydrogen that want to bond, so I'm going to draw these 3 here, and that's pH3. All right, let's try one more. I think I have enough time on this video to do one more. So the next one I want you to try is, all right, let's try one more. Let's try example 8. Let's try CH3CH3. This is ethane. It's a gas. All right, so pause it and try it. Remember that carbon likes to be the central molecule. All right, so what I would start with, I would put my 2 carbons side by side. And how they're written is usually how they're put together. So next to this carbon, we have 3 hydrogen. So remember that carbon has 4 bonding sites. So its 4 bonding sites are going to be taken up by these 3 hydrogens. And this carbon is next to 3 hydrogens. So its 3 bonding sites are going to be taken up with those 3. And now we have to connect the molecule together, so we're just going to put a line in the middle. In talking about this, there are how many single bonds? There are 7 singles. And there are no unshared pairs. You can have no unshared pairs. All right, so I'm going to assign you guys like a molecule builder website. I've been searching for one that I like and one that I think is easy to use. So I'm going to post this video, and then on the video with the molecule builder, I'm going to post instructions on how to use it. Some of you will be able to figure it out right away. Some of you might need a little bit more structure with it. Okay, have a good weekend.